Hello, my name is Tianjia Jin from Group 24 and my matrix number is 22004583. Today we will be solving the speed of the car using ODE method. And here I will be using Euler method for this calculation as Euler method is more simple and easy to code and to solve. So firstly we will have to define the engine force, which we use P divided by V for this equation, and the drag force, which we use this equation to solve, and combine them together using Newton's second law. We will get this equation, which further divide the m to the other side, we will get the ODE equation that we want. And by applying this ODE equation into this Euler method equation, we will get the V that we want to find at each step size. So for the programming part, okay, so for the MATLAB code, we first will need to define the parameters for our situation first. In this case, we will need the mass of the car, the power output of the engine, the air density, the frontal area, the drag coefficient, and the time range for the data, which in my end will be 0 to 60 seconds. So we put here 60 for the time end. And for the step size, we will be using 0.01 for more accurate and smoother graph when it is plotted. So for this part, we will be defining the ODE function into a code right here. And this part, we will be trying to define the initial condition, which in this case, the velocity will be 1, so that we will not have to divide by 0. And this right here will be the time array for our step size, which is from 0 to Tn, which is 60. And this n right here is for defining how much time to loop the Euler formula. And this part right here is for the calculation of the velocity using the Euler method, which is we use for loop here. And this part we will be trying to generate the table for all the data, which right here is the t data, and here will be the velocity data that is calculated from the Euler method. And this time and speed will be the title of the table. This part we will try to display out the table that we generate earlier before, and this part we will be trying to plot the result of the Euler method into a graph, which in this case we also use the data for t and velocity, and here we will be trying to use the display name Euler method, which is like the title for the variables, and this is the title for the x and y labels, and this will be the title for the whole graph. So we click run right here, then yes, the graph will be shown first, and which in this case you see it will show you like the data at each time step, which if we open the command window, it will show us the table for the data, which right here will be 60, and we try to take data for each 10-second interval, as it will be easier to showcase right here. So we will have, let's see, 50 here. We use smaller step size for more accurate.